When you look at the efficiency of a process plant or industrial facility, the asset's total cost of ownership has everything to do with the opportunity cost of unplanned downtime. Unplanned downtime, coupled with poor maintenance practices, cost the global process industries 5% of their annual production. That's equivalent to $20 billion US. 80% of those losses could have been avoided through preventative maintenance.
We bring industrial operations and asset owners together with some industrial service providers or equipment manufacturers so that they can reduce downtime and get equipment back up and running. We showed a demonstrator of a realistic pump scenario in these industrial environments. It's the FlowServe pump. We had the National Instruments test and measurement platform. We used the PI system for the operational view. And we also used components of the PTC platform, which were the advanced analytics for the anomaly detection and also for the augmented reality.
I can tighten down this valve. You'll see bubbles start to appear in the inlet line. And it's predicting that in about 5 days, we're going to have an impeller failure in this pump. When I pull this lever, it's going to cause a shaft misalignment. So the motor will no longer be in perfect alignment with the pump. We can see that we're going to have a bearing failure in 2 days. What we've shown is that the pump is able to distinguish between two different types of failures. And actually, the pump's pretty smart, and it sent me an email saying that, yeah, it's telling me that it's going to have an impeller failure here in a couple of days.
Before, right, you would have to look at a dashboard, and you would look at the piece of equipment, and you'd kind of, in your mind, meld the two together. But by bringing them together in an augmented reality, you don't have to go on that back and forth.
We're able to actually augment real-time data on top of the pump. A technician who had like an iPad or something in the field could see that. We can actually overlay the CAD data on top of that and do an exploded view of what's happening inside the pump, so he could understand how to take it apart and service the impeller and get him back on his way and your process back up and running.
And we're looking for other industrial scenarios and use cases. So if anybody's interested in doing that, we'd love to kind of try these platforms and bring them to those environments. All right. So yes, hopefully you recognize those two handsome devils in the video. There's Ian Fountain and myself. So that pump demo is actually out on the partner showcase, and I encourage you guys to go check that out with the National Instruments guys, the PTC guys, and another partner that's going to demonstrate something on one of our favorite topics, making beer. So the three individuals will come up here. So the first gentleman that I'd like to invite up here, obviously, is Ian Fountain, Director of Marketing for National Instruments. So Ian, go right ahead, buddy.
All right, thank you. All right, so the last session of the day, I'm the last person, or we're the last three standing between you and a cold beverage. So hopefully we'll make this worth your time and have some fun together. And so first of all, I wanted to start off by saying, again, I'm Ian Fountain from National Instruments. For those of you who don't know National Instruments, we don't make calculators, which was the first thing I had to explain to my parents. We are in Texas, and we aren't Texas Instruments, so that's an important distinction to kind of keep in mind. We'll talk a little bit about what National Instruments is doing in this IoT space. We'll also be talking about how we're partnering with PTC and our good friends from RealWear, and how we can put together some pretty compelling and I think amazing maintenance capability that I think is pretty new and fresh, and but it's ready to go today. So I think that's the exciting thing. All right. So I don't know that we're going to have much time for Q&A because we want to, again, get you guys out of here on time. But if you do have questions, go ahead and use the app for that, and we can take care of them later and get that back out to everybody. OK, so with me, I'm Ian Fountain. I'm going to be co-presenting with Manish and Sanjay here. So I don't know if you guys want to come on stage so they can see you. Come on up. All right, so Manish is from PTC and Sanjay from RealWear, and again, I'm from National Instruments. And what we're going to be talking about today is maintenance and how monitoring applications can help out with that. And I think one of the things that we always look for at National Instruments is we're a technology company, but we understand at the end of the day that these technologies have to actually drive to bottom line results for you. And so, this is a nice piece of data that our friends from OSIsoft have kind of brought forward, and it says, there's a lot of wasted money out there in the world, and how can we get in front of that, and how can we actually help bring some of that value back to you so that you can do more exciting things? And so the maintenance strategy objectives at a high level are kind of threefold. One, you can look at it as a way to increase revenue, you can look at it as a way to decrease cost, and you can look at a way to improve safety or reduce risk. And so those are the high-level KPIs that a lot of our customers are asking us for. And so what we're going to talk about today is more of the technology, the how can you go and deliver some of these items. And we don't have a ton of time today, but I'm really interested in having discussions with you to map from the how, from a technology perspective, actually down to these bottom line real dollars and cents. Because that's what's going to motivate your organizations to actually invest in these programs. So that's a topic we'd love to collectively speak with you about. Okay, so one of the things that we've heard from our customers is that they spent a lot of time collecting data. As a matter of fact, they estimated that they were spending about 80% of their time walking around with measurement equipment and collecting data. And unfortunately, they had all this data, and they spent all this time collecting it, but because things happen and stuff comes up, they're only able to analyze about 5% of that data, which kind of seems a little crazy. You spend all this time getting the data and very little time getting value out of the data. And this was a big business problem for one of our big customers, Duke Energy. And we wanted to work with them to try to kind of flip this problem on its head and make it so that the experts could spend more of their time looking at the data and analyzing the data, and the arduous task of collecting the data just happened. And of course, there was a technology component of that. There was a bunch of process and people training components of that. And we're going to talk more about the technology today, but I think it's important to also understand that you have to think holistically about it as a people and process and technology working together to help you solve this challenge. So one of the things that they were really struggling with was, how do you find these engineers? A lot of them have been in the field for quite some time. They're starting to think about retirement, and getting somebody who just has a burning passion to know about every little detail of a pump or a motor, it can be challenging these days. A lot of kids coming out of school want to work for companies that are doing more hip things. And so how do you take some of that knowledge that's built into your workforce and automate it and make it so that you can actually capture it? So that's one of the things that we were really working on. And at National Instruments, we like to think about these problems in sort of three phases: getting the data, doing some analysis with the data, and then presenting that data back to the users to make sure that they can get some value out of it. I'm going to spend most of my time today talking about how we can help you get the data, and then PTC is going to show you a little bit about doing some analysis on that data, presenting the data, and the guys from RealWear will be part of that story as well. Okay, so, sorry about that. One of the things that at National Instruments, we've been around for about 40 years, and we are a very diversified company when it comes to the industries that we serve. And so we serve the automotive industry, we serve the aerospace industry, we serve the oil and gas and the utility space. We serve a lot of these consumer electronics. And so one of the values that NI is able to bring to the table is that we know what's happening in the latest cell phone 5G communication capability, and we can bring that know-how into other industries. And what we've been seeing is that the world is kind of converging, and everything's getting all jumbled together, and people are starting to find value in capabilities and technologies that aren't in their own home market. And so National Instruments brings a lot of that capability to you because we work with the aerospace team. Why would you care about what aerospace is doing? Well, maybe they've got some best-in-class capability that you can learn from, and that's one of the things that we really like to offer. So one of the things that we're seeing is that more capability is being defined by software. Functions are changing rapidly, and we call it increasing complexity in designing and testing, but also increasing complexity in operating those assets. And so we see all of these things, we see it in multiple industries, and we're trying to invest to make sure that you guys can get in front of these things and actually be more profitable tomorrow. And the way that we do that is we have a software-defined modular hardware approach to solving most of these challenges. So how many people have heard of LabVIEW? It's sort of that's the brand that National Instruments is really well known for, and that's one of these productive software environments. But one of the things that a lot of people don't realize about National Instruments is that we're really open we have a very open ecosystem. And so maybe you're not a LabVIEW guy. Maybe you like to do things in web services or Python. And that's one thing that we want to make sure people are aware of, is that you can use our technology with those other technologies. You can also use our hardware with other industry-leading hardware approaches. And so that's the concept of our platform-based approach. Is we want to make it easy to use, but we also want to make it open so that you can bring existing or legacy or new concepts into the platform. So this is an example of some of those types of systems. You see here 2 different types of hardware. The larger white box is used, it's called PXI, and it's typically used in test and measurement and validation applications, so I'll speak a little bit less about it. The other platform is called Compact Rio, and it's used in a lot of these industrial monitoring applications. So it's your -40 to 70 degrees C temperature range. It's got robust shock and vibration capabilities. We support a number of different types of measurement modules in there. We actually have over 100 different measurement modules ourselves. And then it's an open platform, so partners can add their measurement modules into that. And when I say measurement module, what I'm talking about there is it's what you would connect your sensors to. So you have a vibration sensor or a temperature sensor. Those would get ultimately connected up into this platform. And when we were showing the FlowServe pump demo, in that situation, we were using a lot of vibration data, and we were acquiring that vibration data and making it available to the IoT platforms of OSIsoft and PTC through this capability, this Compact Rio platform. And this Compact Rio platform was used by Duke Energy, and I seem to be missing, oh, this slide changed on me, sorry about that. Duke Energy used over 2,000 of those different Compact Rio systems deployed across 60 different power plants, and they were monitoring 10,000 assets. And one of the things that a lot of people would ask is, well, didn't Duke have monitoring systems before? And they did, but unfortunately, because the monitoring systems were so expensive, they were only using them on their most critical assets. And then they actually had a catastrophic fire, and they did root cause analysis on what happened with the fire, and they realized that they lost their turbine because one of the ancillary support pieces of equipment had a thermal event that could have easily been caught with a temperature sensor. And that thermal event, caused a huge fire, and that ultimately took out a very, very expensive asset. And so that really caused this, it catalyzed their organization and said, okay, we've got to do something about this. And they went after a very aggressive balance of plant asset monitoring approach. And that, in order for that to work for them, they had to have a price point that actually could scale across 40,000 sensors, 10,000 assets. And that's where National Instruments was able to bring a lot of our off-the-shelf technology, help them reduce that price point and scale this out. And they've been running this system for about 5 years now, and they've caught multiple potential catastrophic events and saved themselves a ton of money. And we've actually got some documentation and some proof that we can share with you if you'd be interested in learning more about that. Now, one of the things about that system, though, is when we asked them, okay, hey, we can build these data acquisition systems and we can create all this data, what do you want us to do with the data? And they looked at us and said, well, you should put it in Pi, of course. And that's where the National Instruments and OSIsoft relationship was created. We weren't really doing that much with Pi and OSIsoft before that, but this unique customer brought us together and helped us partner together and learn how we can add value to each other's ecosystems. So this is an actual monitoring device actually deployed out in the field. You can see this stuff is, it's ready to be integrated in a cabinet. It's not IP67, so you can't spray it down and get water all over it. We are working on technology like that. We're also working on, a lot of times people want to know, what are you doing in the wireless sensing space? That's another space that we're investing in right now. But the basic concept here is you have the various sensors from your various assets wired up to this monitoring device, and that monitoring device then is able to do the data acquisition and edge processing on that data so that you're not trying to take 100 channels of vibration data, each channel being sampled at probably sometimes around 10,000 samples per second, and put all that data up into your network. That doesn't make a lot of sense, and most networks aren't designed to handle that. So these edge devices are intelligent, they do feature extraction from the data, and they only send the data that you actually need and want when you want it. Okay, so with that, I'm going to pass it off to our friends at PTC who know a lot about what to do with the data that we're producing.
Hey, thanks, Ian. So a little bit about PTC. We are a $1.3 billion enterprise software company, public company for 30 years. We're focused on enterprise solutions in the product lifecycle, so designing products, manufacturing products, and then servicing the products. So what we're here to talk about is our IoT platform, which is a business we started about 3 years ago. And pardon the color scheme here, but we are that bottom layer, if you will. ThingWorx is the name of our IoT platform. And if you think about IoT, a lot of the value is delivered in the form of applications. And it's a hard problem to solve. You got to take care of connectivity, security, performance, scalability, before you can think about your particular business problem, which is monitoring turbines or ATM machines or whatever assets that you're focused on. So what we do is provide a general purpose platform and let our partners and customers focus on their business problem and get to market faster. So that's the premise of the platform. So we do 5 things with the platform. One is source data. So we've got some edge technology, so we can embed in devices or on gateways to collect the data. We also more and more work with OT systems. That's really why we're here today with OSI Pi. Today we just put out a press release talking about a strategic relationship and our integrations with OSI Pi system. So OSI is already connected to millions of sensors and tens of thousands of equipment. So we want to be able to harvest the data and extend the value of all that investment you've had into IoT. So that's the couple of different ways to source the data. Next is contextualize it. So bring in business system data. So your maintenance data might be in an IBM Maximo. You might have customer data in a Salesforce application. Your ERP system, homegrown application. So we bring in data from other systems to contextualize the data about the asset. And the third thing is synthesize or analyze the data. So once you have the OT and the IT data, that's really when you can really perform your analytics, whether it's predictive or prescriptive or other kinds of analytics. And then finally, orchestrate. So if you need to take an action like shut down the pump or slow down the flow or open a service ticket, that's the next thing in the platform that you can achieve. And then finally, you can engage with humans. So if most of these are machine to machine so far, but people get into the conversation as well. So we can deliver applications in the form of mobile or web apps today, but also in the future, you actually see one of the solutions today on stage here in the form of AR and VR applications. So those are all the capabilities we bring to the table with the platform. So we today have an integration with OSI Pi, and we'll strengthen it in a couple of releases in the next few months here. Really we read in both the asset framework data as well as the data itself from Pi. So you don't have to throw away all your work. You can recreate, or you can take your asset framework to create the thing model that gives you the operational view of your asset, but then you can augment with the other data about the service or the customer or the product to you, and create a sort of a 360 view of the asset, sort of a digital twin of the asset within ThingWorx. And then for predictive analytics, we again use the asset data as well as the historical data that's stored in Pi to create the model, the analytical model automatically within our machine learning algorithms. Once you have the model in place, then you can score new fresh data coming in to see what sort of prediction that the system can make. Just like when you were to get a new car loan, they run through a credit check to see how qualified you are for that loan. Similarly, every new fresh piece of data being collected through Pi into ThingWorx gets scored. In this case, you can see what's the likelihood of the pump failing, or if it's engine risk, or whatever models that you have built in place. And then you can take the necessary action through the orchestration layer. So a customer example, Flowserve, a big, large industrial pump manufacturer. They have like 3 million critical pumps out there in oil and gas and pulp and paper and other industries. And so they really wanted to monitor their solution. Today, the way they handle the problem is they have lots of inventory in the right locations, a lot of service techs. It's a huge investment for them. But with more proactive monitoring, more predictive monitoring, they can get to a much lower cost footprint with their solution. They can even get into pump as a service, change their business models itself. So this is a solution we assemble with these partners, National Instruments, HPE, and then OSIsoft to put together a solution. So this is a quick sort of a high-level graphic of the solution. You can actually see this working at the expo. Come down and check it out, and the application in detail as well. So that's a quick summary, but I'll hand it over to Sanjay next. Thank you.
Thank you, Manish. So I'd like to talk about visualization of this data, but not in the control room and not at your PC, but for the field operator who has to work out in the plant, often perform all kinds of maintenance and manual tasks which require the use of their hands, require the use of safety equipment. RealWear is an industrial wearable manufacturer. We make the world's first head-mounted tablet, which you see attached to this MSA hard hat. And we're going to show you an architecture for how one can visualize data from PiVision, formerly known as CoreSight, if I could say that, using a wearable. And I'm going to try and do a live demo. So firstly, the scenario, the Devil's Canyon Brewery, which is in San Carlos, California, about 30 miles from here. It's a craft brewery, has 18 fermenters, makes really great beer. And their process, like all breweries, is a batch process. So this is what they have prior to us coming in with Pi System and National Instruments. They had unconnected programmable logic controllers measuring temperatures and set points on 18 fermentation tanks. They had a manual logging procedure for specific gravity measurements, critical measurement in the fermentation of beer. They transferred those manual logs to a binder. Once in a while, they typed them into a spreadsheet on a PC, and that was their analytics. Not exactly real time, worked, but has some limitations when you try and scale up production. And so we came along and we instrumented, together with National Instruments' help, using the Compact Rio platform, a number of the fermentation tanks. In fact, this fermentation tank on this banner is about half size of the real one that's 35 miles away in San Carlos. This is fermentation tank number 6 out of 18 in the brewery. There's a thermocouple and a few other sensors, CO2 and pressure CO2 sensors in there as well. Goes into the Compact Rio platform. That is then connected through the cloud to the Pi system and the PiVision server. And we are going to view some of that data on this wearable device, the RealWear HMT1, or head-mounted tablet. So if I can move to the demo, please. So you are seeing on the projector what I am seeing in my micro display. It looks to me like a 7-inch tablet about arm's length away. It's, as you can see, quite detailed. This entire device is hands-free, so I've re-enabled the voice recognition, and I will now start up CoreSight. My programs. CoreSight. It's a little app that's going to visualize CoreSight data for us. Okay, now it's looking for a QR code to log me in. There's one on that tank, in the real tank in the brewery, and there's also one on this picture of the tank. Let me go and scan that. Got the tank. We've got an error there. Here it comes. Okay, so what you're seeing now is live data from this brewery tank, from this fermentation tank. You see CO2 pressure. You see specific gravity. That was a manually entered measurement because it's a manual procedure, but the data's in Pi system. And you see the current live temperature of 32.877 degrees Fahrenheit off fermentation tank number 6. This is live data. Show temperature graph. So now what we're seeing is a visualization that is actually hosted on PiVision, and we're looking at a web object that was built by PiVision that's now encapsulated in this native Android application, which has full hands-free voice control. I haven't had to swipe or use any gestures or use my hands at all. This is the 5-day history of that thermocouple on tank number 6. It shows that beer was brewing quite happily until it reached a certain point in its fermentation, and then they crash the temperature by using a glycol chiller. Takes a few hours to get down to 32 Fahrenheit, where it has now stayed until they're ready to go ahead and bottle it. And I can go back to show gauges. As you can see, it's entirely hands-free and voice-driven. Okay, so there's something else I can do with this system as well. And so what I'm going to do is go back to the home screen, navigate home, my files, and scan bookmark. There's another QR code on this tank up here. Go look at that one. Accept. Okay, so that actually brought up from the cloud an engineering drawing of this fermentation tank. So we've contextualized this asset, which is a live asset, not only with live data visualized in CoreSight, but with other data about the asset, in this case, the mechanical drawing of this exact tank. Zoom level 3. Zoom level 3. Control document. And I can look around this and look at the detail of the drawing if I want, find the exact feature that I need to look at, freeze document, and now I can do my task with my hands free, perhaps maintain this tank, perhaps change a fitting, do whatever I need to do. Navigate home. If we can go back to the slides, please. So the second demo that you saw, by the way, I'm just going to easily move this out of the way. It's one of the best features. The second demo you saw was scanning this bookmark, which is associated with metadata in our cloud, which associates where that document is in the cloud, including its page number, zoom level, coordinates, so that I get just the right framing. And in just a few seconds from scanning the physical asset, I can see the actual data. And indeed, this service goes nicely alongside the other data we get in CoreSight. So a little bit about the product. Let me just mute it. Mute microphone. There we go. So it is a full Android tablet, a very powerful Qualcomm-based system with an 8-core processor. It's rugged, 2-meter drop test, IP66, fully dustproof and waterproof. There is an intrinsically safe model that will also come out later in the year, which is a full FM C1D1 ATEX Zone 1 product. And it has a full shift or 8-hour battery life. It can also do video streaming for remote assistance for technicians, data entry, work instructions, all manner of applications that you could run on any full-featured, recent, fully powered Android tablet, but totally hands-free. And so if we refer back to what was done there at the Devil's Canyon Brewery, they were able to actually take the data, the manual process, and by connecting it to the cloud using data in Pi system, we're able to actually get more real-time analytics, actually visualize those analytics and the key steps in the process in real time. And so each brewer operator can know what the next step is as they are in the operating brewery, which is a wet and chemical environment. And there are things like text alerts, which will alert the head brewer when the next step should occur, when the temperature needs to be changed, when something needs to be added to the recipe. As a result, these tanks don't sit idle with finished beer in them, nor do they risk spoiling a batch. So they get better asset utilization. And also, they get a lot more productivity out of the workforce. So as the volume of the business grows, which it is, they can actually make their existing operators more efficient, more productive, and hands-free, so they can increase capacity without having to hire more people. So I hope you can see how visualization on industrial wearables can bring a new dimension to the data that we see in Pi Vision. Thank you.